So guys, now we'll be starting with our second generation of LangChain called LCEL or LangChain Expression Language. So nowadays, actually, this is super important concept. If you want to use LangChain, so you have to know about LangChain Expression Language. So LangChain has created the second generation of LangChain. So previously the LangChain we used to use, this is called legacy LangChain. Okay. So I'll give you the introduction of this entire LangChain expression language. We'll be also learning about what is runnable chains. Okay. So here each and everything we'll try to master. So let's start with our LCL concept. First, I'll be discussing about the runnables. Second, we'll be discussing about LCL chain, like how we can create a chain with the help of LCL. So it is nothing but sequence of runnable. Sequence of runnables. Then third, I'm going to discuss runnable execution order. Then runnable execution alternative. Okay, alternatives. So some of the topic we'll be discussing in the next session. Okay, so let me write down what are the things we're gonna cover inside this LangChain expression language. Okay, and apart from that there is nothing. So 5, we'll be discussing about some built-in runnable and function. Then we'll be discussing about basic LCL chain operation. Okay, chain operation. So these are the agenda, okay, through our entire this LangChain expression language series. Now let me tell you where we'll be using this LangChain expression language. I think we saw the like high level architecture of any kinds of Gen AI application. Let's say first of all, what we do, we give the data input, yes or no, data input. Okay, so after giving the data input, what happens, guys? Some action has happened. Action happens. Actions. So inside actions, I think you know that what we create the prompt. Okay, then we create the chain. Okay, then what we do, we use so many runnable. Okay, then after that what happens, we pass this data to the LLMs and LLM will give me output. So this is the high level architecture of generative AI. First of all, we have to give the data, then some action will be happening. Let's say it will create the prompt chain and all. After that, this data would be passed to the LLM. Okay, then it will give me the output. So here we'll be using the LCL in this section, LCL. Okay, so here we'll be applying this LangChain expression language. Okay, so the same thing, whatever things you have learned so far, everything will remain common. Only whenever you will be doing the action, that means you'll be creating the prompt, you'll be creating the chain. Okay, so there actually you have to use this LangChain expression language, that means second generation of LangChain. Only the syntax would be different. Okay, so the previously we used to use some let's say a predefined function, chain function. Okay, but now what you will be doing, you will be using this LCL technique. Okay, this is the idea. I'll also show you the documentation, like what is the change they have done. I think then this part would be more clear. Okay, so let me open the documentation, LangChain expression language documentation from the LangChain. See what they usually do, instead of using the predefined chain, they use the pipe symbol to create the chain. Okay, now if I show you the older one, see this is the older chain approach. So here we are having different kinds of chain, you can see. Okay, different kinds of chain functions. So let me show you some of the chain. So let's say this is one of the chain, retrieval QA, this is one of the chain. Then you are having Kuzu QA chain, then see LLM math chain, LLM checker chain. Okay, so these are actually chain. Okay, these are actually chain function inside LangChain. and that was the legacy LangChain. Okay, this is the legacy LangChain technique. So let me show you one of the code example. Let's say I want to use this retriever QA. So this is the example of the retriever QA. So you have to import this retriever QA chain from the chain itself. So this is the legacy LangChain, guys. Okay, that means this is the older LangChain, first generation LangChain. Then what you have to do, you have to initialize your LLM, create the prompt. After that, this prompt and whatever LLM you have defined, you have to pass inside the chain. You can see, first of all, I'm giving the LLM, then I'm giving the prompt. Then you can perform the actually invoke operation. Okay, after creating the chain, you can perform the invoke operation. That means you are using some predefined function. Okay, predefined function from the LangChain itself, and this is the legacy example. Okay, now what is the newest one, the newest version of the LangChain? So this is the newest one, guys. Okay, this is the LangChain Expression Language. So they created another version of the LangChain, which is called second generation LangChain, and they're suggesting try to use this particular approach right now, okay, to create the chains. But see, it's not like that always you have to use this new approach. Okay, still they're recommending you have to use the legacy LangChain. In some of the application you have to still use the legacy LangChain. Okay, so now you will have one question like, what is chain exactly? Okay, so let me show you some of the demo. Some of the example I have already written. Let me just show you on my board. See, so what is chain, guys? Chain is nothing but it performs several action in a particular order. Okay, yes or no? So here I think you know that we created a chain and it is following one order. First of all, we are defining the prompt, then the model, then output parser. I have given one basic RAG example with the help of LCL, and there I use this syntax, I think, guys, remember. So you can see here I'm performing some step of what? Step of execution. That means perform several action in a particular order. So these are nothing but action. We are performing some action. So prompt is one of the action, model is one of the action, output person is one of the action, and these called actually runnables. Okay, these called actually runnables. Why this is called runnable? Because it's a executable. Okay, it's executable. You can see prompt is an object, then model is an object, output person is also an object. That means you can execute them. Okay, then you can perform the invoke operation. So whenever you are performing the invoke operations, what is happening? First of all, it is invoking the prompt. First of all, it will prepare the prompt, then it will invoke the model. That means this prompt will pass to the model. Okay, then it will invoke the str output parser. That means it will give you the output. That means what is happening? First of all, you are executing the prompt. Okay, the output of the prompt would be input of the model. Okay, then the output of the model would be input of the output parser. That means it's following one sequence. And what is the sequence it is following? It is following left to right sequence. Okay, left to right sequence. Always try to remember whenever you are creating this chain, okay, inside LangChain, the execution would be left to right, not right to left. Okay, left to right it would be. And if I show you the legacy LangChain, legacy chains, you will see that instead of using that symbol, actually pipe symbol, what we are doing, we are using the function create retrieval chain from the chain, and here we are passing it, and there order doesn't matter. Okay, here order doesn't matter. You can either pass LLM, either you can pass prompt. Okay, so that's why there are some people actually who prefers this legacy LangChain format. For them actually this one actually a little bit confusing, but there are some people they actually prefer this particular new syntax because it's easy to write. Okay, it's easy to write because here you don't need to import it and you don't need to pass it here, because see, you can see after importing it I need to pass this prompt, LLM and all, then again I have to give the retriever and all. But here you only just need to use the pipe symbol and you have to mention the executable, sorry, runnable one by one. Okay, that is the idea. So now I think you got some idea about the this one, your chain. Okay, what exactly this chain, and what is the LCEL, that means LangChain Expression Language, because it's a second generation LangChain. Let me show you the introduction of it. Like chains are sequence of actions with input or output data. Then since the emergence of the LCEL, LangChain is favoring LCL chains over the traditional legacy built-in chains, but these are still maintained, okay, and frequently used. That means see what they are telling, although actually we are having this LCL, that means LangChain Expression Language, but still in some cases actually you have to use the legacy LangChain. Okay, because still it is under maintain. Okay, so they are maintaining it. So in some cases actually you have to use the legacy LangChain. Okay, it's not like that always you have to use the second generation of the LangChain. Okay, So because see, LCL is still it is still under development. Okay, they're also adding new things here. Okay, so that's why they are suggesting to use the legacy LangChain in some cases. Fine. So now let's create one basic this one basic chain with the help of our second generation technique. So here I'll be creating a notebook 06 LCEL. So guys, I think you already know, first of all, I have to like load my OpenAI API key because I'm going to use my OpenAI model. You can also use any other model, like you can use the Grok API. You can also load any open source model. Okay, it's up to you. Then after that, I'm loading the chat model. I already told you we'll be using chat model going forward because chat model is the most used model nowadays. Then here is the basic syntax of the LCEL. I think previously I also showed you. Okay, then I told you we'll be discussing about that. Okay, in detail. Now see, I have written the same syntax. So here I have imported the output parser chat prompt template. Okay, inside chat prompt template, I have given my prompt template. So tell me about tell me a curious fact about. You can give any kinds of politician name, sports name. Okay, it's up to you. Then here I've created the chains. Okay, so the first like component will come the prompt. Then the second component will come the chat model, and the third component will come the output parser. Why? I already told you it's a step of execution. Okay, first of all, prompt will be executed, then chat model, then output parser. So if you do the invoke operation, let's say politician is equal to, I have given a JF key, that means Kennedy. So what will happen? First of all, it will create the prompt, the entire prompt. So inside politician, JF key will come, then it will create an entire prompt, then it will pass to the LLM. Okay, LLM will give the response, and this response will take the output parser. And what LLM gives the output, guys, I think you know, it will give you the AI message output. Okay, so I have to take the string output. For this, I'll be using str output parser. Now see, this is the actually output I got. Because what happens actually, see, whenever you are using LLM, so by default, what will be the output it will give you, guys? So I think you remember, it will give you the output in a AI message format. Let me show you. See, AI message format. Okay, AI message format. But I don't need the AI message format. What I need this string output. Okay, so to get the string output, I'll be using the output parser. So output parser will automatically extract the content. Okay, extract the content from the response, and it will give me. Okay, now I think you are clear. Okay, why? Actually, we are following the sequence. See, always try to remember, whenever you are using LCL technique, you have to follow the sequence. If you are let's say not giving the proper sequence, it won't be working. So first of all, prompt, then chat model, then output parser. That means left to right, you have to create it. Okay, so now let me show you some LCL introduction, like what is the main goal to use the LCL and all. So here is the example. See, LCL has become the backbone of the newest version of the LangChain, because LangChain is updating their let's say code base frequently in today's world. Now traditional chains are still supported, but treated as legacy and has less functionality than the new LCL chains. That means whatever legacy LangChain we are having, okay, you can also use them, but it is having some less functionality than your new LangChain. Okay, new LCL, that means second generation LangChain. That means nowadays, whatever, let's say new functionality they are adding, let's say they are adding, I think you know, they are adding what? LangSmith. Okay, LangSmith, then LangGraph. Okay, then LangSharp. So all the LLM ops tool actually uses this LCEL. Okay, LCEL. That means this second generation of LangChain. Okay, it supports. Now let's see, you are working with the legacy LangChain. That time what will happen? You won't be able to use, these are the new functionality. Whatever new let's say tools and technology they are proposing in their framework, you won't be able to use them. Okay, if you're using the legacy LangChain. But if you're using the latest, that means the second generation of the LangChain, that means if you are using the LangChain expression language, that time you can use these are the tools and technology very easily, because it already supports them. Okay, so that's why here I have written many a main goal of the LCL, make it easy to build chains in a compact way and supports advanced LangChain functionality. That means whatever advanced LangChain functionality people have created, all the LangChain all the let's say advanced functionality can supports that particular LCL technique. Okay, I hope it is clear. But there are some drawbacks. Many students struggle with the LCL because the let's say syntax we usually write, it would be a little bit confusing at the very first time. Okay, because if you are already, let's say, familiar with the legacy LangChain, whenever you are coming to the LCL, some of the syntax would be a little bit confusing for you. That's why many students struggle with the LCL technique. But no need to worry, I will explain in a simple manner. This concept would be more clear. Okay, now let me show you one legacy LangChain example. Okay, so for this, what I will do, let me just comment here. Legacy chain example. Let me show you. So this is one legacy chain example. So here I can use my chat model. See how we are creating the chain. First of all, we are importing one LLM chain, and this LLM chain is available inside legacy. Okay, legacy chain, if you just find here, you'll see that this LLM chain is available. Okay, now let me open it up and you can see the example. First of all, you have to import it. Okay, see LLM chain, first of all you have to import it, then inside that you will be passing your prompt as well as the LLMs. Okay, so same thing actually we are doing. So first of all, we are importing LLM chain, we are getting the prompt template, then inside the chain we are passing the chat model as well as the prompt. Okay, now see, first of all we are giving the chat model, then we are giving the prompt. That means order doesn't matter here. If you're using legacy chain, that means order doesn't matter, you can pass anything. But whenever I were using LangChain Expression Language, LCL, that time order is matter. First of all, you have to give the prompt, then chat model, then output parser. Okay, now here you are doing the predict operation, but here you are performing the invoke operation. Okay, now see, if I execute this code, it will still work, but it will give you some deprecation warning. See, it will give you this nasty warning. Okay, it will tell you this is LLM chain was deprecated in LangChain 0.1.17 and it will be removed in 1.0. Okay, so use Runnable Sequence instead that. Okay, Runnable Sequence means the latest LangChain. That means they're telling just try to use the pipe symbol. That means LangChain Expression Language. See, they are also suggesting in the warning. Okay, so that is what actually I'm telling you. See, it is still people are using, but going forward actually they may remove this particular, let's say, functionality from the LangChain itself. So you have to work with the latest version of the LangChain, but still they are suggesting try to use the legacy LangChain as well in some other use case. Let's say you are having some advanced use cases, that time you can also use that one. Okay, because inside LCL so many functionality as of now they haven't integrated. Okay, still it is under development. That is the idea. And if I want to do it with the help of our LCL, so this is the syntax, guys. First of all, prompt, then model, then output parser. Okay, output parser. See, and there is no warning. Let me show you another example. Let's say this is another example. Here I'm creating a prompt template. So this is the prompt template, guys. You can see, tell me a curious fact about soccer player. So here you can give any kinds of soccer player as an input. Then I'm initializing the output parser. You can also store inside a variable and you can also pass. Okay, it is also possible. Now prompt, chat model, output parser, and here I'm doing the invoke operation and input I'm giving Ronaldo. Okay, now if I execute, first of all it will create the prompt, then it will go to the chat model, then it will give you the output. Okay, this is the output. Now let me show you the runnable order. Okay, what is the runnable order? It is following. So for this I'm going to use one image. So this is the image, guys. You can see this is the runnable execution order in LangChain expression language. Okay, and what is runnable? I already told you. Okay, these are nothing but our runnable. So see, the action you are running now, this is called runnable. Prompt is a runnable, chat model is a runnable, output parser is a runnable. Okay, because you can execute them, that's why we call it as a runnable. Apart from that, we are also having some built-in runnable. I'll tell you, I'll be discussing those built-in runnable as well. Okay, so first of all, let me show you the execution flow. See, first of all, what is happening? I think you remember here we have passed this particular, we created this prompt, tell me about the curious fact about soccer player, and this soccer player we're taking as an input from the user. Okay, now whenever you did the invoke operation, that means first of all it will invoke the prompt. Okay, and it will create the complete prompt. You can see it is creating the complete prompt. So that means user is giving the like prompt, that means the input soccer player Ronaldo, and whenever it is going to the prompt, here, okay, it is creating the entire prompt. Tell me a curious fact about Ronaldo. See, tell me a curious fact about Ronaldo. Then this particular output will go as an input to the LLM model. LLM model will accept, you can see the next runnable is my chat model, that means my LLM, and LLM will take it and it will give you one response. Okay, the response actually we got, you can see the response we got, AI message. Okay, it will, how it will give you the response, it will give you as an AI message, because by default LangChain labels the output as an AI message. Okay, and inside that I'm having the content. Now what I will do, I'll pass this output to the output parser. Okay, output parser will only give the content. You can see I'm passing to the output parser, and output parser is only giving the content. Okay, see, it is only giving the content, and this is my final output. So this is the runnable execution order inside LCL. Okay, that means left to right execution. Okay, I hope it is clear, all of you. That means we have discussed, these are the thing. We saw the runnable sequence of runnable execution order. Now let's see some runnable execution alternatives. Okay, instead of invoke, what are the method we can apply on top of runnable? Okay, let me show you. So instead of invoke, you can also apply a stream as well as the batches. Let me show you some example. So let's say this is my chain I have created. Now instead of giving the invoke, you can also use the chain, stream. And what is stream, guys? What is stream? I think you know that. If I go to the chat GPT, if I open the chat GPT and if I ask something, it will give you as a stream output. Okay, let's say here I can give, tell me about Ronaldo. See, it will be a stream output. See, after one word, another word is coming. Okay, it's a stream output. But whenever I used to perform the invoke operation, it will give you the output in just one shot. But if I want to get the stream output, that time we'll be using the stream. See, chain.stream, and here instead of politician, I'll give the soccer player. So soccer player, I'll give Ronaldo. Okay, now see, you have to write inside a for loop. Now if I execute, see, it would be a stream output. Okay, so it is telling it doesn't have any content. Let me check. Okay, so if I want to get the stream output, that time content I don't need. If I execute it, now see, so only you just need to print this, because output parser will automatically give you the content, so you don't need to get the content. Now whenever I execute it, you will see that it would be a stream output. See, it is streaming output. After one word, another word is coming. Okay, then let's say you are having some batches input. Let's say instead of Ronaldo, you are also want to give the Messi. Okay, and you want to get the response for both of the input. So that time you can use the batches. See, this is one of the example. So instead of stream, at the time you have to use the batch. So here you can give soccer player. I'll give Ronaldo as well as the Messi. Okay, now here I'm passing inside a list. Okay, you can see I'm passing inside a list. First of all, it will take the Ronaldo, it will generate, then it will take the Messi and it will generate. Let me show you. See, this is the Ronaldo and this is the Messi. Okay, so this is called actually runnable execution alternative. That means instead of invoke, okay, instead of invoke, you can also use other function. Let's say you can use stream as well as the batches. Okay, I hope it is clear. Now one thing actually this second generation LangChain will give you, and this is like very powerful, which is called LCL chain or runnable can be also used asynchronously. Okay, asynchronously. That means you can execute simultaneously. Let's say you are having two runnable. You are having, let's say, prompt, then you are having chat model. So these two operations you can run simultaneously. That means it can perform the invoke operation at the same time. Okay, I think you have learned about the parallel. Okay, parallel computing and all, I think multi-threading and all, right? So this is the similar kinds of concept. Sometimes what happens whenever you are implementing any big application, right? Any big application, there you will be creating very complex chain, yes or no? So there would be so many chains. Let's say C1, pipe C2, pipe C3, pipe C4. Okay, that's how it would be a long chain. Okay, that time if you are following the sequence of order execution, okay, that means this particular simple chain, So it's following sequence. First of all, prompt template will execute, then chat model, then output parser. But whenever you are getting complex application, if you're following the sequence, it will take lots of time to give you the input. So that time what happens actually, it runs actually asynchronously. That means parallelly it will run. Okay. For this, we'll be learning some built-in runnable inside LangChain. In the next class, we'll be learning some built-in runnable inside LangChain. This is the agenda. So guys, as I already given you the introduction of this LangChain expression language, and I already told you why it is important and how this works. Now we'll be discussing about some built-in runnables, okay, inside LCL, that means LangChain expression language. So this is super important concept if you're learning LCL. So you have to know about this built-in runnables. So let's try to see some practical demo of this. So inside built-in runnables, you are having some runnables. Let me just write one by one. So first of all, you are having something called Runnable PassThrough. Okay, Runnable PassThrough. Then you are having a Runnable Lambda. Runnable Lambda. Then you are having Runnable Parallel. Okay, parallel. So inside Runnable Parallel, you are having one very important thing called item getter. Okay. Yes. So these are the very frequent used runnable. Okay, inside LCEL. That means LangChain expression language. So if you see any kinds of implementation, so people are using, these are the runnables. Okay. So here I'll show you each of example of the runnables actually I have listed down here. Okay. First of all, we'll try to understand the runnable PassThrough, Runnable Lambda, then Runnable Parallel. Okay, everything we'll try to explore. Now I think you remember, guys, in my previous session I was talking about the runnables. So what exactly the runnables? I think you remember, guys. Remember what exactly the runnables? Let's say, I think you remember we created a chain. So here maybe I can show you the code example, that would be fine. So this is my LCL notebook. So here you can see I created a chain, and to create a chain, guys, what I did, I used some of the runnables. Okay, runnables is nothing but it's a executable. Okay, that means it's a sequence of executable. That means you are performing sequence of action here. So prompt is one of the action, chat model is one of the action, and output parser is one of the action. That means first of all, prompt will be creating, this prompt will pass to the chat model. That means whatever output you will be getting from the prompt, that would be an input to the chat model. Then chat model will return the output. It will be taking this str output parser and it will give you the output. Okay, that means this is my runnables. Okay, these are my runnables, these are my executable, and with the help of this runnable, with the help of this pipe symbol, what we are getting, we're getting the chain. Okay, it's the step of execution. Now inside LangChain, inside second generation of LangChain, they created some actually built-in runnables. Okay, these built-in runnables will help you to build this chain in a more, let's say, advanced way, in a more, let's say, powerful way. Now let me tell you how we can use them all one by one. So let me create a notebook here first of all. So I'm going to name it as 07 LCL. Okay, LCL built-in runnables. So let me select my kernel. So the first thing, I'll be loading my OpenAI API key. You can also load your Grok model. It's completely fine. Then we'll be initializing our LLM. So here we'll be using chat model. That means GPT 3.5 Turbo model we'll be using. Okay. So the first thing I'll be discussing about Runnable PassThrough. Okay, Runnable PassThrough. I think you remember I have written here Runnable PassThrough, and this is a built-in runnable. Okay, now let's try to understand what is Runnable PassThrough. See, it does not do anything to the input data. Let's see it in a very simple example. A chain with a just Runnable PassThrough will output the original input without any modification. So let me show you one example. Let's say this is the example of Runnable PassThrough. So it is available inside LangChain code. Okay, you can see it is having one function called runnables. Inside that, we are having different kinds of runnables, like Runnable PassThrough is there, then runnable lambda is there, runnable parallel is there. Okay, different runnables are available. That's why we call it as a built-in runnable. Okay, built-in runnables, because it is already built in inside LangChain. Now here we are creating an object of the runnables. Okay, and we are naming this object as chain. So let's say I'm creating a simple chain. This chain only perform runnable pass-through operation. Okay, why runnable pass-through operation? Because I want to show you the runnable pass-through example, like what it will do exactly. So here I've already written it does not do anything to the input data. That means whatever input you will be giving, the same input it will give you as an output without doing any kinds of modification. Okay, let me show you one example. So I think you remember we can execute the invoke method on top of any kinds of runnable, any kinds of executable, yes or no. So we can do it. Let's say here I will call chain.invoke. Okay, chain.invoke. Inside that, let's say I will give my name, Bappy. Okay, let's say here I've given my name. Now see, if I execute this line, so what will happen? It will give me Bappy as an output. Okay, why? Because here I told you it does not do anything, okay, to the input data. That means whatever input data you will be giving, it will return as an output. That's it. So this is the example of runnable pass-through. That means it will only pass through your input. Okay, pass through your input and it will give you the same output. Got it? Now you can ask me, what is the use of this runnable pass-through then? Definitely there is a use of, because whenever you will be creating the chain, so the first thing what user will do, guys. So let's say whenever I'm creating any kinds of, let's say LangChain project, or let's say LLM powered project. So the first thing, user will give the input, right? Okay, user will give the input, and this particular input I have to take as it is. So whatever format they are giving, I have to take as it is. Okay, so we'll be handling with the help of runnable. Okay, runnable pass-through. Okay, so that is the idea. That means whatever input data user is providing, you will be handling through this runnable pass-through. This is the idea. Now second, let's try to understand the runnable lambda. Then we'll be combining all of them together. Okay, so we can combine all of the runnable all together. It is also possible. Let me show you. So let's say this is the runnable lambda example. You can see, to use a custom function inside LCL chain, we need to wrap this up with a runnable lambda. Let's define a very simple function to create a Russian last names. Okay, so what I'll show you guys, I'll show you one example. Let's say here I created one function called Russian last name. If you see any kinds of Russian last name, you will see this particular word called ovis. Okay, ovis, any kinds of name. Let's say you can give let's say Abram, you can give Bappy, you can give, let's say any name. You will see that this would be the spelling at the last of that particular, let's say, name. Okay, that's why here we have created a function called Russian last name. This will take one input called name, and name should be integer, string, and it will also return as a string output. And here I'm returning, guys, here I'm writing a f string. Inside that, whatever input user is giving, that is whatever name user is giving, I'm just adding with this obvious. Okay, that's it. So now let me execute. Now let me show you one example how this will work. So let's say this is my function. Inside that, if I give, let's say, Bappy, you'll see that with Bappy actually it will add this particular word called obvious. Got it? Now let me delete it. It's not required. Now, in order to use this function inside my chain, okay, we'll be using runnable lambda. Now let me show you one example. So here is the example, guys. So you can see I'm importing this runnable lambda from the runnables, from the LangChain code. So the first runnable will be adding the runnable pass-through. Why runnable pass-through? Because I think you know this sequence of execution. Remember, guys, sequence of execution. Whenever we are creating any chain, C1, C2, okay, C3. So I have to go left to right, right? Left to right. So the first of all, what user will give? User will give the input data, yes or no? User will give the input data. This input data I have to receive. And how we can receive? With the help of runnable pass-through. I think you saw one example here. So with the help of runnable pass-through, we can take this input, and this input will give me the same output as it is. Okay, so that means whatever input user is giving, it will come here, then it will return. Okay, it will return to the runnable lambda. That means this will go there. That means left to right. Input will come here, it will return as it is. Okay, the output of the runnable pass-through will be input of the runnable lambda. And what runnable lambda is doing? It is taking one function. Okay, it is taking one function called Russian last name. Okay, now I think you remember, guys, lambda function. Do you remember the lambda function inside Python? So inside lambda function, I think we used to also do the same thing, yes or no? Or maybe you have learned about higher order function inside Python. Okay, this is the similar kinds of concept. That means a function is taking another function as an input. Okay, this is called higher order function. Now this function is doing, It is just adding this particular obis at the last of the name. Okay, now let's say if I execute this chain and if I show you the output, so what will happen? So let's say I'll execute. Now if I just write, let's say chain dot invoke, and if I now let's say give Bappy here. Okay, if I give Bappy here, so I'll give my name, just a minute, Bappy. Now see what will happen. Now see, if I execute, it will give me Bappy obis. Why? Because first of all, Bappy will go inside Runnable PassThrough. Runnable PassThrough will return this Bappy as it is. Okay, as it is. And then it will come to the Runnable Lambda. Runnable Lambda will take the Bappy and it will execute this particular function, the function you are giving as an input. So this will add this obis with my name. Okay, so this is what actually we are doing. Now you can see with the help of multiple runnables, we can create a chain. So this is the idea, guys, inside LangChain. LangChain is nothing but you are creating the chains. You are creating the sequence of execution, sequence of action. Okay, the action you want to perform with your data, with your large language model. Got it? So this is what actually chain. Now this is the simple chain we have created. Going forward, we'll be also creating complex chain. We'll be using retriever. There will be using vector database and all. Okay, with the help of that, we'll be creating the complete chain. That means the RAG chain and all. Everything will be creating. Got it? Now the next one we'll be learning about Runnable Parallel. So this is, guys, one of the very important runnable inside LCEL. That means without that, you won't be able to create any kinds of big application. Let's say whenever you want to create any kinds of bigger application, let's say you want to create a complete chat GPT kinds of, let's say, chatbot. It's a bigger application. So lots of people will come, they will give the different prompts. They may pass is short prompt, bigger prompt. Okay, anything they can pass. So now if I want to handle this kinds of, let's say, execution, that means whenever I'm talking about big application, that means your chain would be also big. So whenever you are creating the chain, let's say C1, C2, and C3 and so on, right? Your chain should be also big. So let's say if I'm following the simpler approach, that means the sequence approach, that means left to right. First of all, this chain will execute, then this chain will execute, then this chain will execute, and so on, right? Now you can see it is taking time now. First of all, this will complete, then this will start. This will complete, then this will start. So it is time taking. So it will be taking time as per the user input, as per the chain, okay, chain size in the application. So what we can do, guys, we can utilize the multi-threading approach here. That means we'll be running everything in the parallel. Okay, let's see if I'm having a very big chain and and with the help of that, you are getting the big application. That time we can execute in parallel. So I think you know multi-threading, parallel computing, yes or no, right? So at the same time, we can execute multiple operation. This is called actually parallel. Okay. So in LangChain also, it is provide actually Runnable Parallel. That means we'll be using Runnable Parallel for running tasks in parallel. And this is probably the most important and most useful runnable from LangChain you will be using going forward. Go ahead. Now, there are some way actually we can write this Runnable Parallel. First of all, I'll show you the easy one. Okay, easy one. So this is the example, guys. So this one, Runnable Parallel example. You can see I'm importing Runnable Parallel from the Runnables inside LangChain code. Now here I'm defining one object called Runnable Parallel. Inside that, I'm giving two tasks. You can see the operation A. Operation A, actually, I'm taking the Runnable PassThrough. And what is Runnable PassThrough will do? I do remember. Here, Runnable PassThrough. It will only return the same input. The input actually will be giving. So we are already familiar with the Runnable PassThrough. And the second operation, we are performing Runnable Lambda. That means the same thing. And what Runnable Lambda will do, it will take another function and it will perform the job. Okay, that means higher order function. You can see. Okay, now, you can see the both operation I'm passing inside Runnable Parallel. Okay, that means this two operation will execute at the same time. It's not like that. First of all, it will complete, then it will start. No, it will start at the same time. It will also start. Okay, that means you can let's say execute this particular application in a very short period of time with the help of parallel computing, with the help of parallel, Runnable Parallel. Okay, this is the idea. Now let me execute and let me show you. So let's say here I will run this chain. Let's say chain.invoke. I'll give Bappy. Now see if I execute. So here you can see operation A, Bappy is coming. Operation B, Bappy, OBC is coming, because here you can see it is also executing this particular function. Okay, so this is called Runnable Parallel. And this is the most used runnable you will be using inside LCEL. You can add as many as, let's say, runnable you can. It's not like that you are having some restriction. No, you can create your chain as complex as you can. Okay, it's up to you. Now let me show you another example. Let's say, so we'll be adding some more, let's say, runnable with our chain. So for this, I'm going to use my LLM. So first of all, I will import this to library str output parser and chat prompt template. What is output parser? I think you already know. So here I already showed you the example in my previous session. Okay, output parser, it will give you the output as a raw text, that means the string. Okay, and chat prompt template, why? Because I am using the chat model. If I want to create the prompt template, I have to use the chat prompt template. That's it. Now here I'll initialize my prompt template as well as the output parser. You can see I'm initializing both. So this is my chat prompt template and this is my template I created. Tell me a curious fact about this. Is the input user will give me. Okay, soccer player, and this is the output parser object. Now here I'm going to create another higher order function. That means the same Rashi and last name from dictionary. Okay, that means whatever name user is giving, it will add the OBC here, and it will add from the dictionary right now. Okay, we'll be giving the dictionary as an input. From the dictionary itself, it will take the name. This is the idea. Now we'll be building the runnables. See, that's how we can build a multiple runnables. You can see runnable parallel. Now inside operation A, it will do the runnable pass through. That means whatever input you will be giving, the same input it will give you as an output. Now the second thing, soccer player, that means runnable lambda you are executing. That means the input you are giving. Let's say we have given Messi. Okay, so what it will return, guys? It will return Messi only because you can see runnable pass through you are executing, and runnable pass through will return as it is. Then the second execution we are doing runnable lambda, and inside that we are executing this function, and this function will add the OBC here, right? That means if I'm giving Messi, so it will happen, it will return as a Messi OBC. Okay, Messi OBC. And the second last operation we are performing the runnable pass through again. That means whatever Messi OBC it is returning, same it will take the input and it will give you the output, because again you are running the runnable pass through. Okay, in case you can also take any other runnable, it's up to you. Now here, after creating this runnable parallel, we are passing this output to the prompt. Prompt will give to the model and model will give to the output parser, and output parser will give me the answer. Okay, so this is called actually multiple chain. Okay, multi-chain we have created. Now inside that, let me give some example. Let's say this is the execution I'll be doing. Name 1 is equal to Jordan and name is equal to Abram. Now you can see this particular function takes the name. Okay, name key only, but here I have given name 1. So whenever this will go here, it will take only this particular name because it is matching with this particular key. That means Abram will be taking. Okay, now let me show you. If I execute, so see, one curious about Roman Abramovic. See, it is giving the Abramovic because it is taking this name, not this name, because this key is not messing here. Okay, I hope it is clear. You can also delete this part, but I've given as a dictionary input. That's why I've kept actually multiple key value here. Okay, just to show you. Now you can see whatever let's say name you are giving, it is returning here. This name is coming here and it is giving the Ovic. That means Abramovic, and this Abramovic is again coming here. Runnable pass through. It is again returning the same thing. Now it is coming to the prompt. Okay, now what would be the prompt? Tell me about a curious fact about Abramovic. Okay. Then this particular prompt you are passing to the LLM. LLM is taking the entire prompt and it is giving you the output, and you are applying the output parser on top of it, and output parser will give you the raw text. Okay, that means the string output. This is the idea of the runnable, that means our parallel runnable. Now let's see some advanced use of parallel runnable. So now we'll be using the vector DB technique. That means we'll be creating one RAG. Okay, with the help of RAG actually we'll be learning this runnable parallel. So initially I think you remembered we already created some RAG, right? And there I already used LCL technique, and there I used the basic technique actually. Okay, I was not using any kinds of runnable pass through and all. So here you are already familiar with what is FIAS, what is str output parser, what is chat promptlet, and what is runnable pass through and runnable parallel. And from OpenAI we are importing chat model and OpenAI embedding. Okay. As of now, let's try to consider this is my data. Okay, I'm not opening any kinds of data, txt file, pdf file, I'm not opening. I'm directly passing the data, and this data is, you can see DS with Bapi focuses on content on data science, artificial intelligence, ML, DL, CV, NLP, Python programming, and so on. Okay, now this text I want to convert to the numerical representation. For this, what we'll be using, guys, we'll be using embedding model. You can see I'm using OpenAI embedding model, and whatever embedding I'm generating, I'm storing in the FIAS vector database, and I'm creating the vector retriever. I think you know what is retriever. Okay, I already explained. And this is my prompt template. So I answered the following. I answered the question based on the only following context. That means whatever retriever you are created, this is your context, and this context actually it will take, and whatever question user is asking, it will take and it will give you the answer. So here I'm creating the prompt template, initializing the chat model, and now this is my chain. Okay, this is my chain. Now you can see I'm using Runnable Parallel. And inside Runnable Parallel, first of all, I'm mentioning the context. That means the retriever. Then the second, I'm mentioning the question. That means whatever question user will give. That means first of all, it will initialize the retriever and then the question. Now you can see this execution will be happening. Now whenever you will be executing the code, it will be happening parallelly. That means at the same time, okay, at the same time, these two operation will run. Okay, and whenever at the same time two operation is running, that means you are getting quick response from your application, yes or no. Otherwise what will happen? First of all, this will run, then this will run. Okay, and it is time taking. But if you are utilizing your parallel, okay, parallel, let's say computing and all, that time you will see quick response you will be getting. Okay, so that is why we'll be using Runnable Parallel. And to define Runnable Parallel, you can use this approach. Either you can use any other approach. I'll tell you what are the approaches are available. Okay, now after that we'll be giving the prompt. That means whatever output we'll be getting, let's say my input is what is DS with BAPI. So first of all, it will give the retriever to the context. Okay, you can see this is the context. That means the entire retriever will go to the context. And question, what is the question? This is the question user is giving. What is DS with BAPI? So this question will come here. You can see Runnable with the help of Runnable PassThrough, it will store here. And your prompt is also taking the question. After that, it will create the entire prompt. Entire prompt means answer the question based on only the following context you have given, as well as the question you have also given. Okay. Now this will give you the entire prompt. Now this prompt you will be passing to the LLM, that means model. Okay. Now model will apply this prompt and it will give you the response. And this response you are passing to the str output parser because it will give you the string as an output. Okay. Now this is my question, guys. What is DS with BAPI? And you can see this is a simple RAG we are implementing. Now see if I execute it, so it will be able to give me the answer about DS with BAPI because here I have given the information of my data. Now you can see DS with BAPI is a platform that focuses on providing content like data science, AI, ML, civil, NLP, Python programming, etc. in English language. Okay, now see, amazingly it is running. And the execution you saw, okay, the execution you saw, it's like quite amazing because it is running in the parallel. Okay, it's a simple example, but going forward, we'll be creating very complex application. There we'll see that inside parallel, okay, inside Runnable Parallel, you can add so many runnables, you can add so many executables, so many actions. Okay, it's up to you. Just to give you the understanding, I'm giving you, let's say 3 to 4 examples, but whenever we'll be building the project, that time you'll see the complexity. Got it? Now, I think I told you there is another things inside Runnable Parallel called IMGetter. Okay, now let me show you one example of IMGetter. Okay. So this is the example I already prepared. So you can see I'm importing this IMGetter from operator. Okay, operator is a library inside Python. So here I'm importing it. Then I'm importing files, output parser, chat, template, Runnable PassThrough, okay, OpenAI and so on. That means whatever things we imported previously, the same thing we're importing. So creating the model, creating the vector store retriever template, and see inside template the modification I did here. Insert the following answer in the following language. So here user can also specify the language, like in which language you need the output. So here you can see this is the prompt, answer the question based on only the following context, and this is the question user is asking. And here user is specifying I need the answer in the following language. Now you can give any kinds of language. You can give Spanish, you can give Pirates. Okay, you can give any kinds of language. Okay. Now see, I'm creating the prompt template, and this is going to be my chain. Now see, now I'm executing this particular this one, your Runnable Parallel. Now you can ask me, sir, what is Runnable Parallel? Because previous example you showed me, this is the Runnable Parallel. I was using a function. Okay, I was using the function from the LangChain. Okay, yes or no? Runnable Parallel, you can see we imported. But here we are not using this Runnable function. Let's say, Runnable Parallel. Okay, we are not using Runnable Parallel, but you are telling this is a Runnable Parallel execution. Okay, why? Because inside LangChain, they will give you actually different kinds of way actually you can define this runnable. So let me show you. So here I have taken one screenshot. So this is the screenshot. Let me open up my Blackboard and let me show you here. See, there are some several way you can define this Runnable Parallel. So the first way you can define like that. We have already learned, right? Runnable Parallel, inside that you can define the context, retriever, question, pass through. Then the second way you can define that, you can, instead of taking the string, you can directly give as a variable name. Okay, inside that you can pass. And this is the third way. Okay, now see, here I'm not using this Runnable Parallel function. Okay, I'm not using it. Instead of that, I'm using this particular bracket. You can see I'm using this curly bracket. Okay, and whenever you can see this curly bracket, that means it is using the runnable parallel runnable parallel executor. Yes, that means whenever you can see this particular bracket, that means this curly bracket, you have to remember they are executing something called runnable parallel. So by default, LangChain actually created this thing. So they are telling just instead of calling the function again, we can use this bracket. So for the fresher, it would be a little bit confusing initially, but if you practice, if you just, let's say, implement the product regularly, definitely you will make a habit on this. Okay, so this is how actually you have to use this runnable parallel. Okay, so I showed you 3 different syntax, guys. Now you can use any of them, but this is the most used one. If you open up any kinds of documentation, if you open up any kinds of example of the LCL, you'll see that people are using this particular approach, okay, instead of using the functionality they're giving. Okay, now you can see inside that I'm having the I'm getter. Okay, now the example I showed you here, inside example, what is the changes I have done? The changes I have done, the answer actually I also want to specify the language. That means this particular application takes 3 input. The first input is the context, second input is the question, and the third input is the language. Okay, now you can see I'm taking the input one by one from the user. Okay, so the first thing will be taking the context. Okay, that means the retriever with the help of I'm getter. Now the second thing will be getting the context question, okay, from the question, and the third one will be taking the language. Okay, with the help of I'm getter, you can see the language. Now after getting it, this is my parallel. Okay, this is my parallel actually runnable. That means all the 3 operation you have written, it will execute at the same time. Then it will pass it to the prompt. Prompt will create the entire prompt. Then it will pass to the LLM, and LLM will give me the response. And this response actually I'm converting to the string output. Okay, and here is the input operation we are doing. So this is my question, and this is my language. That means I want this particular response to be in a pirate English format. Okay, now see if I execute the program, you'll see that it will give me the answer in a pirate English format. See. Harem eti DS with Bappy is a scaling, but blah blah. You can read it out. Okay, so this is called actually pirate is English. So now you can give anything, Spanish, Hindi, anything you can give, it will give you the same output. Okay, now let's see, whenever you are having the multiple input, that time you can use this IM getter. Okay, inside runnable parallel. Okay, so these kinds of functionality LangChain also will give you. First thing I'm going to discuss built-in functions in Runnable. Okay, built-in functions inside Runnable. Then second, I'll be discussing about how we can combine. Okay, combining chains. Okay, like we'll be creating chains inside a chains. Okay, multiple chains actually we'll be using. Then at the last, I'll show you one basic RAG demo. Okay, RAG demo. I think you already created the RAG. Okay, RAG, let's say example with the help of LCL. I think remember whenever we started with the RAG, that time I showed you, right? Now I think again I will show you this demo, and it would be clear now. Okay, the syntax actually I was using that time. Now it would be clear. Okay, how we can create the RAG with the help of LCEL. That means LangChain Expression Language. Okay, so this is the complete agenda. So what I can do, I can close it, and let's create another notebook here. So here I can name it as 08 LCL. Okay, LCL little more. I can just write like that. IPYNB. So I'll select my kernel. Now the first thing, I'll be loading my OpenAI API key. So let me load. You can also use your Grok model. Now let's initialize my chat model. Okay. Now, if I want to create a basic chain, guys, with the help of LCL, guys, how to create? I think you remember. So first of all, let's import str output parser, then chat prompt template. Then let's create the prompt template as well as the output parser. Okay. So this is the prompt template we have created. You can see, tell me a curious fact about soccer player. So you can pass any kinds of soccer player name. Okay. Now let's do the invoke operation. So here I will pass. So first of all, I will create the chain. So you can see chain is equal to prompt, model, and output parser. Okay, sequence, left to right sequence. Then I'm doing the invoke operation, soccer player. I'm giving Ronaldo. Now, see if I execute, it will give me one curious fact about Ronaldo. See, Ronaldo's full name is Cristiano Ronaldo dos Santos Aveiro. Now, if I again execute, it will give me another response. See, okay, because it's a generative model. So every time it will generate new response for you. Got it? Now, there is a inbuilt function inside Runnable. Okay, we'll get. So one inbuilt function actually we are having called dot blind. Okay, dot bind, I think, sorry, dot bind, B-I-N-D, dot bind. Okay, so this is the inbuilt function. So what is the use of dot bind? See, I have seen like very less use cases of this dot bind, but sometimes if you need it, you can use them. Okay, now let me show you one example. So here, let me just write. Let me comment so that you can revise later on. You can see use dot bind to add arguments to a runnable inside LCL chain. For example, we can add an argument to stop the model response when it reaches to the word of Ronaldo. Let's say whenever Ronaldo is coming, that time your execution will stop. That means your response will stop automatically. Okay, so if I want to, let's say, have this kinds of condition, that time I can use this dot bind function. Okay, how? So let me show you one example. So here, what I will do. So the chain, see, I'm going to create like that. Similar chain I have created, guys. You can see prompt, model, okay, then output parser. Now, one thing I have added, one inbuilt function, because see, everything is everything is a executable. That means everything is a runnable here. Okay, this is a runnable, this is a runnable, this is a runnable, this is executable, this is executable, this is executable. That means we are performing some certain action. Okay, now inside every runnable, you can use this particular actually inbuilt function. So the inbuilt function name is bind. So here I'm applying on top of the model because I want to stop the model whenever it is reaching the condition to the Ronaldo. That means whenever Ronaldo is coming, it will stop the execution. It will stop giving you the response. Okay, so here I'm calling model.bind and stop is equal to Ronaldo. That means whenever Ronaldo is coming, just try to stop the response. Okay, this is what actually I'm telling. Now see if I execute. So first of all, let me do the invoke operation. Now see if I execute. So whenever it will generate the response, whenever Ronaldo will come, it will stop the execution. See, again, let me execute. See, one curious fact about Cristiano. Now, whenever Ronaldo was coming, it will stop the execution. Okay, so that's how we can use this dot bind function. It's a inbuilt function inside Runnable. Got it? So very simple use case, but I have seen like very less, used in the application building. But sometimes if you want, let's say if you want something like that, you can use this particular dot bind function. Even LangChain team is also telling there is like very less use of this particular function, but if you need it, you can use them. Okay, we have created for you. This is the idea. So the next thing we'll be learning about combining chain. That means the next topic, this one is done, combining chain. That means how we can create a multiple chain inside a chain. Okay, so we call it as a combined chain inside LCEL. So let me comment here. Okay, combined chain inside LCEL. Now, first of all, you can define the chat model. Now, first of all, let me create a simple chain. So here you can see I've created a simple chain, the same example. Tell me a sentence about the politician. So here I'm giving the example of the politician. You can give any kinds of example. This is my model. So model I already defined. I can remove here. Yeah. And this is my chain, guys. Prompt, model, and output parser. Okay. Now let me execute. Now see if I do the invoke operation. So let's say I'm giving one politician name. So this is one. So he's the politician. Okay, politician, you can say British politician. Okay, and Prime Minister of the United Kingdom. So here I'm giving this particular, let's say, input. So now if I execute, it will give me one response of this politician. See, this is the response actually I'm getting. Okay. Now, let's say what I will do, I will give another. I'll create another prompt. Now I'll be creating the combined prompt. Combined chain. Okay, combined chain. That means we'll be using the previous chain as well as the new chain. So how to do it? So this is the code example. See, output parser we already imported, so I don't need to import. I can remove it. See, so chat prompt template, we are getting another template. You can see was politician positive for the humanity. That means the politician you have asked, let's say this politician Chamberlain, okay, Chamberlain. So whatever response actually you are getting, it will be giving it here. You can see the chain actually I have created previous chain. So here I'm giving as an input to the politician. That means whatever response I'm giving, I'm getting from my previous chain, I'm giving as an input to my next chain. Okay, and here I'm telling was the politician. That means the response actually I was getting of the politician, it was positive for the humanity or not. Okay, now the second chain it will identify. Say first of all we are giving the first chain, then the historian prompt. That means this prompt, the new prompt I have created. Then again I'm giving the model. Okay, the model actually I have defined. You can see the model actually I have defined. Okay, then I'm giving the output parser. Okay, now see if I execute, see what will happen. So here I will give now I'll give another, let's say, politician name called Lincoln. Okay, Lincoln. Now see if I execute, what will happen. See yes, Abraham Lincoln is considered positive for the humanity because of his leadership during critical time in American history. Okay, now see how it is working. First of all, it is whenever you are giving the invoke operation politician is equal to Lincoln, first of all it will execute this particular chain. Okay, and in this chain you are creating another chain of the previous chain. You can see the previous chain you have defined. Now it will go to the previous chain, that means the politician. Okay, politician, you can see. So it will go to the politician. And what is the politician name? What is the politician name? Politician name is Lincoln. So what it will do, it will tell me a sentence about Lincoln. Okay, and it will give you one sentence about the Lincoln, and that sentence actually will be giving to the next prompt. Okay, that means historian prompt. Now it will tell was this Lincoln, okay, positive for the humanity or not. Then this will go to the model. Model will identify was Lincoln is the positive for the humanity or not. Then it will give you the response, and that response actually you are able to see. Okay, that means you are creating chain inside a chain. This is called actually combined chain. Now let me show you another example. So this example will give you the clear-cut idea. See, this is the example I have prepared. See what is happening. First of all, I'm importing some necessary library. I think you already know. Then I'm creating the prompt one. So this is my first prompt template. So what is the country politician is from? That means you will be giving the politician name and it will tell you the country. Okay, country the politician was from. Then the second prompt I'm creating, what is the continent of continent is the country. Okay, the country, that means the country you are getting from the first prompt, you will be giving the input to the second prompt. Okay, in and respond in the language. That means it will, you can also give the language as an input. That means it will give you the response in that specific language. Okay, now this is my chat model we are defining, and then we are creating the first chain. First of all, you can see the prompt one, then the model and the output parser. Okay, then we are creating the second chain. So inside second chain we are defining the first chain. You can see the chain actually we have created, this one, chain one. So here we are giving, okay, then the language. So user will also give the language, then the prompt 2. Okay, the prompt 2 actually you have created, then the output parser. Now whenever you are doing the chain 2 dot invoke operation, so you are giving the politician Mitterrand and the language French. Okay, now what will happen? First of all, it will come here. Okay, and you will see that it has to execute the previous chain. And what is the previous chain input? So it will take the politician. Okay, it will take the politician. So this politician will go here. So it will return the country that politician actually was from, and it will return. Then the second chain will execute, and inside second chain what you are doing, you are giving the country name. Okay, the country name you are getting, you are giving the country name, and you are asking for the continent in which language, your specific language, which is nothing but French. Okay, now see if I execute this chain, you will see the output. See, this is the output actually we are getting in French. Okay, so that's how we can combine multiple chain, guys. It's not like that we have created 2 chains. You can create 3, 4, 5 and so on. Okay, that's how we can increase the chain complexity if it is required. Now the last example I'm going to show you, this RAG demo. So let's create one basic RAG demo. So here what I will show, I'll first of all write one comment. So LCL chain at the work in a typical RAG app. So I think I already showed you the RAG app, right? So let me again show you how we can get the RAG. So first of all, let me define my chat model. Okay, now here is the entire demo of my RAG. See, instead of loading any kinds of PDF documents or let's say TXT document, what I'm doing, I'm loading the data from the URL. So you can see And I already taught you how to load the data from the URL. So LangChain is having different kinds of data loaded. So this is the URL, guys. So from this URL, we are extracting the information. You can see. So this is the topic related LLM powered autonomous agents. Okay, you can see this is the one blog actually they have written. So what I will do, we'll just try to extract all of the information, and on top of that, we'll be building one RAG-based application. I can see I'm using web-based loader. With the help of web-based loader, you can extract any kinds of information from the website. So with the help of this web browser based loader, you can load any kinds of URL. Okay, and from that URL, you can extract any kinds of information. Now here you can also specify the class. Let's say you only need to extract the page content, post content, okay, and post title and post header. If you see any kinds of, let's say, website, and if you, let's say, open it with the help of this one, view page sources, okay. Now inside that, you will see different kinds of class. You can see they have written the class. So let me show you. If you understand the HTML actually syntax, you will be able to understand what I'm trying to say. So class is there, I think somewhere. See, class is there. Okay, class is there. Now see, class is header is there, page content is there, sorry, post content is there. Okay, that's why we are having different kinds of class. You can see. So here I'm telling I need the post content, post title, as well as the post header. So these are the information it will extract from the HTML page itself. You can see inside HTML page we are having the content. Okay, we are having the content. And if you're using LangChain, you don't need to worry about it. It will automatically find and it will extract everything for you. Okay, this is the advantage you will be getting. So after loading the documents, we are you can see we are loading. Then we are performing that chunking operation. Why chunking operation? Because of the input. Okay, input limit of our LLM. So here is the chunk size and here is the chunk overlap. Then we are getting the you can see chunk. Then we are using Chroma DB vector database and we are storing the vector. We are converting all the text into the vector and we are storing inside Chroma DB. Then we are getting the retriever. Okay, and I need a prompt. Okay, either you can write a manual prompt. The way actually we have created the prompt here, I think you remember. That's how we can create a prompt. Either you can download any kinds of prompt from the hub. Okay, prompt hub. So here you can see LangChain is also having the hub. Let me show you. So you can copy this syntax and you can simply search here. So see LangChain example LangChain. So guys, you can see this is the prompt. Okay, this is the prompt, and if you want to get this prompt, so you have to use this syntax. So LangChain import hub and hub.pull LM rag prompt. Okay, and if you execute it, it will give you this particular prompt. Okay, this prompt it will give you. So this is what actually we are doing. Instead of manually writing, we are downloading from the hub itself. So inside hub, you are having different kinds of prompt. Okay, this is another way you can define the prompt. Then I think you already know what is the function about. That means whatever response you will be getting, you'll be only extracting the page content. You can see we are passing this particular function here, and this is my rag chain we are getting. So curly bracket is nothing but it's a parallel. Okay, parallel runnable. I think you remember. So we already taught you na. So runnable parallel. So instead of using the function, we are using the curly bracket, and inside that we are like passing the context. That means the retriever, format documents. Okay, then question, the runnable pass-through. That means whatever question user will give, and these are the three runnable will execute at the same time because we are executing inside the parallel runnable. Okay, this is the idea. Okay, then the prompt, then model, and the output parser. And this is the very common syntax, guys. Okay, this is the very common syntax if you are implementing any kinds of application with the help of second generation of the LangChain. Everywhere you will see this syntax. Now I think you will be able to understand. Okay, if you see any kinds of project, okay, of the LangChain second generation, you will see this particular syntax. Now you won't be having any kinds of doubt. Now simply I can give one prompt here. So what is the task decomposition? You will see that inside the content actually we have loaded. So there they have also mentioned task decomposition. Okay, inside this block actually. This block. Okay, task decomposition. So this is what actually we are asking, and this is the response I got.